So let's continue the current electricity from the arrangement of resistor. From what? Arrangement of resistor. So the resistors, in the previous class, I've explained the terms resistor as the opposition of the flowing of current in the circuit. And the factors that affect resistor, so we have length, cross-sectional area, resistivity, which is nature of what? Of wire on material, and the effect of temperature on resistor. So our major interest now is what? How are we going to arrange the resistor in what? In the circuit. So the resistor can be arranged in the circuit in two methods. The first one is what? By parallel connection, and what? By series connection. So let's start from the parallel, or by saying resistor, the resistor can be arranged by the following by the what? Following methods. So the first method that we can apply for the arrangement of resistor, I can say we have by parallel circuit connection, and the second one by what? Series circuit connection. So those are the what? The two methods that we can apply for the arrangement of what? Of resistor in the what? In the circuit. Excuse me. So let's start from the what? From the parallel circuit connection. Parallel circuit connection. So by the parallel circuit connection is, so what? The parallel circuit connection can be defined. The what? The parallel circuit can be defined as having more than one current path. More than what? One current path to connected to a common voltage. A common what? Voltage source, which is battery. Common voltage what? Source. So excuse me. The parallel connection, I will show the what? The diagram now. Is the connection. If you have a circuit in this form, have a circuit in this form, Good. Can you see this circuit? We can observe that what? This is the battery source. What we call what? I call it what? Voltage. The battery source, say I call it what? Voltage, which is what? V. And this is what? R1, first resistor. R2, this one is what? R3. So we have three resistors here. This first resistor, the second, and third. And here, if current is moving from the source, current I, getting to this point, this is what? The direction of the current. The same current get to this point. At this junction here, the current split into three. We have I1 and we have current what? I2. At this side, we have current what? I3. So you can, and the current I1, I2, and I3, the later meet back at this what? At this point. So this is the what? The structure of what? Of parallel connection. I said a parallel connection circuit or a parallel circuit can be defined as the one having more than one current path connected to a common source of voltage. So current 1, 2, 3, the source for first current I1, I2, and I3 is what? Is the voltage. So any circuit that is what that is their resistor, they are in this form, we call it what? Parallel circuits connection. And in this parallel circuit connection, from this sketch, we can observe yes, from this is parallel connection, we can observe that is what? The same voltage pass through the what? The three resistor, 1, 2, 3, but different what? Current. So if you look at it now, you can say that what? From this expression, we can agree that current I what? This I is equal to what we call what? Current what? I1 plus current I what? I2 plus current what? I3. Because this I1 that splits to I current I splits to the what? I1, I2, I3. So this is what we can call this equation what? Equation 1. And this equation 1, under DC circuit analysis, there is a theory called Kirchhoff's law of current. So we will soon get there. And the next thing that we need now here is what? We can observe that from onwards, Ohm's law, the voltage is always proportional to the what? To the current of the what? Of the circuit. So I cannot say from Ohm's law, From what? Ohm's what? Ohm's law. We say that what? V is equal to the what? I R. So from this expression, do you know that is what? We can agree that current I is equal to what? V R. See, if it is true for this, let's substitute for what? For this current I from Ohm what? Ohm's law to this equation what? 1. By doing that, what happened here? I will be what? V over what? Over R will be equal to what? What is I1? Abi, you can see that the I1, the current of I1, the resistor for I1 is what? Is R1. Resistor for I2 is R2. For I3 is R3. You can now have what? V over what? I what? I1. This I2, which will be what? Voltage over what? R2. The R3 will be what? V over what? R3. Why is it that the voltage, we don't put what? V1, V2, V3 here? The R1, R2, R3, and the current, they have the same voltage. They have the same voltage. Check it here. They have what? Common voltage source, which is V. So from there, we can take what? The voltage out, we have 1 over what? R will be equal. Here, they have voltage in common. Take it out, we are left with what? R1 plus what? R2 plus R what? R3. So this voltage, we cancel the voltage. We have 1 over what? R1 plus 1 over what? R2 plus 1 over what? R3. This is the formula used to find the what? The effective or total resistance in a parallel circuit. In the parallel what? In the parallel circuit what? Connection or arrangement. So, if you are given this kind of circuit, you are now have to find the effective resistance. We apply this formula. But let me add this to it in case of theoretical question. What is the question? You can say that what? Let me add it to it. I can say the mean, yes, the mean characteristics, the mean characteristics of parallel circuits, parallel what? Circuit arrangement or connection. What are the, so this thing have what? Just or 3 characteristics in common. The first one is the same voltage in this circuit. The major thing here is what? The same voltage pass through the what? The 3 resistors. The second one is what? Different current pass through the what? R1, R2, R3. So we can say what? Number 1, same what? Let me write this. The same voltage voltage acts across all the circuits, acts across all the resistors. So the same velocity voltage pass through the what? R1, R2, R3. That's why the what? We take this out as what? As common factor here. So the next one is different resistor have individual current. Yes. You can say what? Different resistor have their individual dual what? Current. You can see it now. The R1, R2, R3, each of them have what? Their own current. I1, I2, I3. But the current they have there is what? Is additive. Now I saw current I1, I2, 3 together to give us what? The mean current. So we can also say what? The branch current. Branch what? Current are additive. You know about additive? That is I equal to the what? I1 plus I2 plus what? I3. So the branch current are what? Are additive. So the next one is the conductance, also additive. Conductance are what? Addictive. And the power also what? Additive. Electric power there are what? Additive. That is what the conductance is what tendency of a wire to absorb or to allow the flowing of what of current. So that is what the conductance for this wire resistor 1, 2, 3, you can add them together. The power in this one, in this R1, R2, R3 are different. You can add them to what? Together. That's the meaning of what? Conductors are additive and power additive. You may ask that is what lists the four characteristics or features of what? Of parallel circuit connection. So these are the main five features of what? Parallel circuit connection. Or if your exam is what? Is a multiple choice question, they will just give you which of the following statement is not correct for the parallel circuit connection. So in a circuit connection, majority of the students will majorly focus on what? On the formula alone. So we have some theoretical question that the formula will not ask. They will just ask you the words, this, which of the following statement is what correct for every parallel connection. The power in each resistors are what are additive. And the conductance are also additive. The branch current also what additive. And the different resistors have their own individual current. This is what happened in the diagram here. And again, the same voltage pass through the what? All the resistance we have what? In the circuit. That is for what? For the parallel what? Arrangement. Let me explain the series arrangement before we solve question altogether. Before we explain the series, let me explain the what? The parallel connection. The advantage and disadvantage of parallel what? Connection. No, the kind of connection we have in our what? In our house or in this classroom, the kind of electrical connection we are using here now. So I'm talking, you can see that in this classroom we have like 3 bulbs here or 4 electric bulbs. So all these bulbs, what kind of what of connection? Is this parallel or series? All the houses, the electrical connection that we are using in our house, in the lab, in the hotel is what? It's parallel connection, is not what? Series. Let me explain the reason here. Under advantage of parallel connection, you may ask, at what advantage of parallel connect connection. So if you are talking of what of advantage of parallel connection, the first thing is light bulb. Mm, light what? Bulb connected or connects. The light bulb we have at home connects in what? In parallel, not in what? In series. Connect in what? In parallel. Mm, let me put it in this way that the light bulb connects in parallel are brighter than the light bulb connected in series. Yes, in parallel are brighter, bright what? Brighter than the light bulb than that of what? The one we connect in what? In series. The second advantage of parallel connection is when one bulb in parallel circuit is blow or is blow, which is what is at fault, the other will continue to what? To glow. But if it's in series, all of them are what? They are in open circuits. So let me say what? When one of the bulb in a parallel, in what? In parallel circuits blow, this one blow means what? It has what? At fault. Other what? Other will continue to glow. We what? Continue to what? To glow. But however, when one bulb in series is what? Is blow, the other bulb will not what? Will not glow. That is, the circuit will become open. Let me put it there. How what? However, however, when a mhm, when one bulb in a when one bulb in a series is what? Is blow. A series is what? Is blow. Then the circuit, the circuit will be open. That is, that is, none will what? Will glow. So that's why the parallel connection is very, very advisable for us to be what to be using in our residential building, not in the office and schools. Because you can have like 3 bulbs in a room. If one blow now, the other one will be what? Will be glow. But if it's in a series connection, if one blow, it will affect the what? The others. So that is what, those are the two main advantage of what? Of using parallel connection in our what? In our house. Then that's the advantage. The next thing is what? Let's look at what? The series circuit connection. Series. Series what? Circuit connection. The series circuit connection can be achieved by connect the R1, R2, and R3 resistance on a straight line to what? With each other, and the same current flow through them. So that's why I say what? If the first one is affected, the other will be also what? Be affected for the series connection. And each resistor will have its own voltage. This potential what? Potential difference. And in the series connection, the voltage are what? Are additive. And the resistor also what? Additive. Which is resistance is also what? Additive. Let us put it down here. This is what this can be defined as a circuit. This can be defined as a circuit. This can be defined as a what? A circuit that contain circuits that contain this can be defined as a circuit that contain only one part for current flow. Only one part for what? For current flow as shown below. Look at the circuit for the series. For series connection, so this is what we call what? R1, this is R2, this is what? R3. If the current starts from the cell here, this is the cell. The current is flowing like this. This is the current I. The same current pass through the what? R1, R2, R3. A circuit that contains only one path for current flow. But in the parallel, three paths, branch paths for current flow. So in this one, this R1 has its own potential difference called V1. This one also has its own potential difference. This one also has its own potential difference. Let me make this one big too. So this is what? V1, V2, V3. And the cell here is the one that is what produces what? The voltage that is here. So from this expression, we can have that what? From this expression, we can have that the voltage is equal to what? V1 plus V2 plus V3. This potential difference here It is the one that contains V1, V2, V3. So from this expression, we can also borrow the what? Ohm's law, saying from what? Ohm's law, where we have what? V equal to the what? I R. Abi now? So yeah, let us insert the Ohm's law value here. By insert the Ohm's law value, this man will be what? I R. Here we have what? I R1 plus what? I R2 plus I R what? 3. What are they have in common? Is current. The same current pass through the what? The three resistors. We have what? I should be R. Take the I out. We have R1 plus R2 plus resistor 3. This will cancel each other. We now have what? R total should be what? R1 plus R2 plus R what? R3. This will be the what? The effective resistance for what? For a series connection. But what are the what? The main characteristics feature of what? Of this what? Of this series connection. You know, in the parallel connection, I said the same voltage pass across the what? The resistors. So here, it's not voltage this time around. What is passed through them this time around is what? The first one is what? The same current pass through the resistors. So the same current pass through the resistors. The number two is what? The potential difference is directly proportional to what? To resistor. That is what? You can say what? The potential difference as well as what? To the resistor. That is, you can say what? Different, I say different voltage. Do what? Different what? Voltage or PD across the resistors, making two. The third one we can say what? The resistance. Let's see what? Resistance are additive. You can see it here. We add them together. So, and the power here also what? Also additive. So those are the what? The four features of the series circuit connection. So this now, let's solve two or more questions on parallel and a series arrangement of what? A resistor.